Hello everyone, my name is Loveleen Kaur, and in this video I will be talking about the algebra of polynomials, and I will be going over unit 5 from our textbook from Math 100, which will cover algebra of the polynomials. In this we will learn how to divide polynomials by using long division and synthetic division. Before diving into the steps, let's briefly talk about what polynomial is. A polynomial is an expression that is made up of variable and coefficients involving operations like addition, subtraction, divide, multiply, and there are different type of polynomials. They're not different type, they're specific names for the polynomial. We just have one term, we call it monomial, and if we have two terms together, we call it binomials, and if we have three terms, we call it trinomial, and if we have four terms or more, we call it polynomials. So these are the specific names for the polynomials, and in a as I told you, it is made up of expression of variable and coefficients. So this is an example of a perfect polynomial. This has variables, coefficients, and it has a power degree, and then it even has just the number by itself. And so let's in this unit we will learn how to divide polynomials using two methods, which is long division and synthetic division, and how to find zero of the polynomials by using remainder theorem, factor theorem, rational zero theorem, and these three theorems to find the function of the polynomials. So let's start a polynomial long division. We will just revise how we used to do normal division with numbers. If I were to divide 2 by 18, how many times do I multiply 2 in order to get 18? I would multiply it 9 times in order to get 18. So I would write it here, and then I would subtract it to get a remainder as 0, and 9 would be my quotient. And now I will show you how to do this with the polynomials. So if I were to divide x by x to the power 3, I cannot just go and multiply x into x to the 3, because I have to see how many times do I multiply x in order to get x to the 3. So I cannot just multiply it, I would have to divide it first. So if you know from Math 099, we had operation of division, which is a to the power p and a to the power q is equal to a to the power p minus q. So a is our x here, x to the power 3, and then a quotient is x by itself, this one. So we are gonna divide this. If we were to divide this, we will get x to the power 3, And one more thing to notice here, this does not have any power to it mentioned. So if it doesn't have any power, we're just gonna assume its power is 1 because x has a power to 1. We don't have to show it, that's why we don't write it, because it doesn't make any difference. But when we were to do that, we always write it as, we don't write it, but we considered it 1. So I'm gonna x to the power 3 subtracted by x to the power 1 would give us x to the power 2. So we can now, this would be our quotient, x to the power 2, and now we're gonna multiply x to the power 2 into x to the power 1 in order to get x to the power 3. So we can do that, x to the power 2 into x to the power 1. Now same thing again. If like this we solve dividing operation of polynomial, same as we had the multiplication operation. So it was a to the power p into a to the power q. We would multiply a's and then we would add the power value. So we would add p plus q, which would give us a to the power pq. Here we're gonna do the same thing. We're gonna multiply x to the power 2 into x to the power 1, we would get x to the power 3. So this would be x to the power 3 into, we get 0, we subtracted, we get 0. That's a remainder, that's our quotient. Okay, so now we have learned how to do the basic of the polynomial. We can apply it to do long division. So for the steps for long division, we have first we divide, then we multiply, and then we subtract, and then we bring down. So these are the 4 steps that we follow. And we have an equation here, x to the power 3, 3x squared plus 3x plus 1. So we are gonna divide that. We have x to the power 3 plus 3x to the power 2 plus 3x plus 1. We're gonna divide it by x. So just like we did before, the first step is to divide. Now we take the first term of the dividend, and first term of the divisor. We are gonna divide that. So just like we did before here, let me do it again actually. So we're gonna do x divide x to the power 3 divided by x, we get x. 3 minus 1, we get x to the power 2. That is our quotient, x to the power 2. And we are gonna, next step is multiply. So we're gonna multiply x to the power 2 into x to, again I'm gonna say this, we have x to the power 1 here. So we are gonna add x to the power 2 plus x to the power 1, we get x to the power 3. So in order to get x to the power 3, we multiply x to the power 2 into x to the power 1, which we get x to the power 3. And now our next step is subtract. We are gonna subtract it, and then we get 0 here. And then our next step is to bring down. So we are gonna bring down this equation here. Plus 3x squared plus 3x plus, I forgot to write 1 here, plus 1. Now we're gonna repeat the same steps. So this time we have x to the power, so we have 3x to the power 3. We're gonna divide it by x. We are gonna get 3x squared minus 1. We will get 3x by itself. So that will be our quotient. It would be in, there's no minus sign here, so it would be plus. So now our second step is to multiply. We're gonna multiply 3 into x. We get 3x to the square. We have our quotient here. We're gonna write it 3x to the square. Since this is a plus, we are gonna subtract, which is our third step. We are gonna subtract, and then we are gonna get 0 for this. This cancels, this cancels. We are gonna bring down plus 3x plus 1. We're gonna follow the same step again. We are gonna divide 3 x we're gonna divide 3x by x. We are gonna get x cancels x, we get 3. We are gonna multiply it by x, and we are gonna get 3x again. That will be our so we can write 3 here as our quotient, and then we multiply, we get 3x, which is gonna be plus 3x, and we are gonna again subtract it, which this will cancel out, and now we are left with 1 as our remainder. We cannot simplify it more because we have x as a variable. We don't have a coefficient, a number term that can be subtract to 1 and give us a 0. So this would be our quotient. This would be our remainder. So in order to write our answer, we are gonna write it as let me write it with this. X to the power 3 plus 3x squared plus 3x plus 1 is equal to, that was our quotient, x squared plus 3x plus 3. And our remainder is 1, which is a plus 1 here. So it's gonna be plus 1 divided by x. This is how we write our answer. Now we have our second equation. We're gonna divide this whole equation by x minus 2. We're gonna repeat the same steps, and this time we are gonna take the first term of the divisor and divide it by the first term of the dividend. So we're gonna take 2x to the cube divided by x, we get 2x squared. Now that we get 2x squared as our quotient, and we are gonna multiply it by this. 2x squared into x minus 2, we would get 2x cubed minus 4x squared. We are gonna write it here, which we get 2x cubed minus 4x squared. So our signs are gonna change. We are gonna subtract everything from here. This is gonna be minus, we get 0, they cancel out, and then we get 5 here. This is gonna be plus, plus, minus, minus. It's gonna stay as minus. We get 5x squared. This is gonna be a plus sign since the bigger term has a plus sign with it. Now we are gonna bring down minus 6x minus 8. We would get, now we would do the same process. So if we do it, we are gonna get 5x divided by x, we get 5x. This is gonna be plus 5x. We're gonna multiply it, x minus 2, we would get 5x squared minus 10x. We would write it here. We're gonna say it's plus 5x squared minus 10x. I forgot to change the colors here, but never mind. Now we are gonna subtract it all. So this is gonna be a minus, change into minus, it's gonna cancel out. This is gonna change into a minus, it's gonna stay as a plus, minus, minus, plus. So it's gonna be plus 4, since a bigger term has a plus sign. So 6 minus 4 is gonna be 4x, which is gonna be plus 4x, and then we would drop down the 8, which is minus. Now we're gonna take 4x divided by x, we would get 4, and then we are gonna multiply it, x minus 2, we would get 4x minus 8. That is our final answer. We are gonna get 4x, and mind you, this is positive here, and then this is negative. We're gonna change the sign. This is gonna be negative, they cancel each other out, and then this is gonna change into plus, they cancel each other out, we get 0. And our quotient for this one is 4, which is going to be plus 4. So this is how you solve the long division. Again, if we want to write it as an answer, we can write it as 2x cubed plus 1x squared minus 6x plus 8 is equal to 2x cubed plus 1x squared plus 5x plus 4 divided by x minus 2. This would be our final answer. Now we will learn how to do synthetic division. Here are some rules about the synthetic division. This only works on a linear divisor, mean a linear divisor we can we can say as x plus 3, x plus 3, this is a linear divisor. It cannot work with anything else. Synthetic division can only be divided by linear binomial. So this is a 2 pair, it is a binomial in a form of x minus 3. So it could be any number, but it has to be x minus a number. Then we have right coefficients only. So if we have an equation, for example, this equation. This is our equation, and we are not gonna write the variable parts of it. We are just gonna write the coefficients, and whatever the sign is in front of the coefficient, we are gonna write that as well. It helps us to get us the better answer. But yeah, we are not gonna write the variables in the power functions. And then our next step is to set up the opposite sign. So if we have, for example, I have x plus c here. As I mentioned earlier, it has to be x minus a digit or a number. So it's gonna be we're gonna do x plus 3 is equal to 0. We're gonna set it equal to 0 to make the equation x to 3. So we are gonna add this on both sides. This is gonna be minus, and then x is gonna be 3 is equal to 0. And then we are gonna bring down our first coefficient, and then we're gonna multiply to the first coefficient, and then we're gonna add whatever the number we get. So we're gonna repeat this process until we are done with all the coefficient. Our last number is our remainder, and then this would result the degree of the quotient will be 1 less than the polynomial. So these are just the steps as I try to do this example. We will learn more about it. So here the first step is to make x minus 3. So here we set it equal to 0. We get x is equal to minus 3. We are gonna put minus 3 here. Minus 3. And then we are gonna divide it by this term, and we're just gonna write the coefficients of this. So it's gonna be plus 1, then it's gonna be there's one more thing I would like to mention here, that as we see these values, they are not in exact order. So this is a quadratic, this is a cubic value. We need a quadratic value here, and then we can write just the 2x to the power 1. So we are gonna add 0 here instead. So we're gonna add 0 to the to fill in the quadratic value, and then we're gonna do 2x to the power 1, and then we're gonna write plus 8. This is plus, this is also gonna be plus. Wait. This term is gonna be in minus here. This is a minus. This equation is wrong. It's gonna be minus. And then it's gonna be 8. So we're gonna divide all this. First step is to drag the first coefficient down. I'm just gonna put a straight line here. And then what we're gonna do is we are gonna take one positive down and we are gonna multiply it to -3. So we're gonna multiply 1 by 3, which is gonna give us, let me just write it here once, into 3, -3. So it's gonna give us 1 into -3 is -3. It's gonna give us -3 as answer. And then we're gonna repeat the same step. We're gonna take this value, multiply it with this, write it here. So it's gonna be 3 into 3 is 9. Minus would give us a plus value. And then we're gonna add all these values. So once we do that, we add all of these values. Once we multiply and then we add. So it's gonna be 7 here. And then we're gonna multiply again. 7 into -3 is -21. And then we deduct, and then if we add, there's gonna be a, let me write it with other color, there's gonna be a plus sign. Plus minus is minus. It's again, we're gonna subtract it and we're gonna get answer as 13. So all we do is we bring down, we multiply, and then we add. This is where we write our product answer, and this is where we're gonna add this is our adding answers. So now we get 1 +1 -3 plus 7 minus 13. And as I told you, we started with the cubic root here. So it's gonna go down to 1 because we bring 1 down, 1 value down. So it's gonna, the degree of the quotient will be the last one. 1 less than the original one. So it's gonna be, if it's a cubic, it's gonna be 1x squared minus, this was supposed to be quadratic, it's gonna be it's gonna be 2x, and then it's gonna be, wait, it's gonna be 1x and then 3x and plus 7. And this is our remainder. This thing here, it is our remainder. The last digit is our remainder always. So our answer is, we had a value 1x to the cube minus 2x plus 8 is equal to 1x squared minus 3x plus 7. And then we get minus 13 divided by x plus 3 was our divisor. And then we write our remainder here, quotient here, and our divisor here. So I'm gonna do one more example equation. I'm gonna first set x minus 2 is equal to 0. I'm gonna do that. And 2 is equal to 0. We get x is equal to 2. Then the next thing we're gonna do is we're gonna write the coefficients in descending orders. We have x to the 4, and then we're going to write x to the 3, then x to the power 2, and then x to the power 1, and then any other variable, any other number that we have. So we're going to divide it by 2. So it's going to be positive 3. We're just going to write the coefficient positive 3, positive 2, and then we're going to write 0 instead of quadratic x here, and then we're gonna write plus 1, and then we're gonna write plus 7. So we're gonna bring down 3, and then we're gonna multiply it by 2. So I'm gonna do this one more time. Into 2, 3 into 2 is 6. 6, we're gonna add all of these terms at the here. So it's gonna be 6 and 2 is 8. We get positive 8, and then I'm gonna do positive 8 into 2. We get 16. So 0 plus 16 is 16, and then I do 16 into 2. We get 31. Oh, mind you, here this is gonna be minus. So this is gonna be minus here from the equation here. It's gonna be minus 1. So if I'm gonna add it, plus 31 minus, it's gonna be 32. 6 to your 12 and 6 to your 2. It's gonna be 32. So if we deduct 1 point, it's gonna be 61, and then if I multiply 31 into 2, I would get 62 again. Let me do it. 7 and 6 into 2, 42, 14, 7, 6, yeah. No, I'm gonna multiply 31. 31 into 2, 3, 2, 2, 6, we get 62. Plus 7, 62, we get plus 69. And this here is going to be a remainder. The last term is always the remainder. And then we're gonna write this down. We're gonna bring down 1 degree, and we're gonna write the answer here. So it's gonna be our 3x to the 4 plus 2x to the 3 minus x plus 7 is equal to, this was 3x to the 4. Now we're gonna write 3x to the 3 plus 8x to the 2 plus 16x to the 1 plus 31. So we're gonna write it as 3x plus 8x squared plus 16x plus 31. And we get our remainder as int plus 69 divided by x minus 2. This is our final answer here. Now we're gonna do the remainder theorem. This is the formula for the remainder theorem. It tells us about that if we divide f of the function x, it tells us that f of the x is x minus a. If we get f of the x is equal to quotient into x into x minus a plus remainder, and then we plug a into both of the sides, we get f of a is equal to quotient a 0 plus r, and then we get f of a is equal to r. So the value of the f of a, the function of a, is same as the remainder when we divide by x minus a. So here we did as x minus c, it's the same thing as x minus a. So it can be c here, it can be a here, that does not matter, it's a formula. So we're gonna put the value here anyway. So first we're gonna do the synthetic division again. Now that we learned the synthetic division, it's gonna be easier for us to do it. First I'm gonna set actually I'm gonna change the color. X, wait, write it with this one, x plus 2, we're gonna make it to x is equal to minus 2 is equal to 0. So now I'm gonna do the synthetic division here. I'm gonna put all the values in order again, and I'm gonna divide it by minus 2. It's gonna be 1 plus 7 plus 5 minus 4 plus 15. So I'm gonna bring 1 down and I'm gonna multiply it by 2. I'm gonna get minus 2. Then I'm gonna add both of these. I'm gonna get minus 5. And then again multiply 5 into 2 is minus 10. And then plus minus minus, it's gonna be minus 5. And then again minus 5 into minus 2, I get plus 6. I mean plus 10. And then if I do that, if I subtract that, it's gonna be plus minus minus, it's gonna be 4 minus 10 minus 4 is 6, and then 6 into minus 2 is minus 12. And then if I deduct that, if I subtract that, it's gonna be 3. That is our remainder. So now we're gonna this was x to the 4. We're gonna bring one value down, one power down, so it's gonna be 1x to the 3 plus 5x minus 5x. It's gonna be 5x squared minus 5x plus 6. And then we get a remainder. It's gonna be plus sign here. It's gonna be 3 divided by x minus 2. Now we are gonna check our answer now. We are gonna check our answer now. So the main point of remainder theorem, what this theorem is trying to tell us, that if we put the x value into x, we set it to x is equal to 2. If we put x into x, we put 2 into x, we would get the same remainder as we got by the synthetic division, by doing the synthetic division. So if we put this minus 2, x is equal to minus 2 here, that we set is equal to 0. So as we got x is equal to minus 2, we can plug this into x to the 4, x to the 3, x to the 2, and we would get the same answer as we got by doing synthetic division. So in order to do that, we did synthetic division, and now we're gonna check our answer. So I'm gonna write down the values here. It's gonna be x to the 4 plus 7x to the 3 plus 5x squared minus 4x plus 15. And x was equal to 2 minus 2 is equal to 0. So I'm gonna set, we had x plus 2 here. I'm gonna set it to equal to 0. So it's gonna be x is equal to minus 2. So I'm gonna plug minus 2 into here. So it's gonna be minus 2 to the 4 plus 7, and then 2 minus 2 to the power 3, and then we have plus 5, and then we have minus 2 to the power 2 again, and then we have plus, and then we have 4, and then we're gonna plug minus 2 again, and then plus we have 15. So now we're gonna try to simplify the solution. We're gonna do 4 times 2, we would get 16. So let's do 2 and 2. 2 is 4, and then 4 into 2 is 8. 8 into 2 is 16. And it's gonna be minus plus, we get 16. And then plus 2 and 2 times 3 is 8, and then we multiply 7 into minus 8, and then we would get 5. 2 times 2 is 4, it's going to be positive 4, and then 4 times 2 is going to be 8. Oh, this is a minus here. So this is going to be minus plus, we would get 8, and then we would get 15. So now we're going to simplify this even more. It's going to be 16 minus 56, 780 of 56, plus 5 for 20, plus 8, plus 15. So now we're going to add all these values first. We're going to add 16, 20, 8, 15, which would give us 16 plus 8, which it would give us 59. Minus, we would get 56, and our final answer would be, it would be 3, positive 3. So we can say that f of minus 2 is equal to 3. This would be our remainder theorem. And now I'm gonna do one more example, but now this time I'm gonna put in the value first and check what answer I get at the end, and then I'm gonna do the synthetic division for it. So I'm gonna put my f of x is 4, the function is 4, I already know that, so I'm just gonna put into the value as for the x. So it's gonna be 2, 2, I'm gonna put 4x to the 3 instead of 4. It's gonna be minus 5, and then x plus 2 would be 4 to the power 2, and then plus 6, and then 4 as instead of x, and then plus 12. So now I'm gonna simplify this. If I do 4 times 3, 4 into 4 is 16. 16 into 4 is gonna be 4, and then it's gonna be 64. So it's going to be 64 minus 4 into 4 is 16. So 4 into 4 is 16, 5 into 16, and then it's going to be 24 minus 12. I am again messing up with the signs here. This is going to be minus 4. Since it was minus, it's going to be minus 12 since it was minus 12 in the equation. So it's going to be minus 12. So now 64. My 5 into 16 is 80. And then we get plus 24 minus 12. If we... This is going to be 2 here. So if we multiply 2 into 64, it's going to be 128, I guess. It's going to be 4 into 2 is 8 and 6 to 12, 16. So now we're going to do 24 minus 12. We get plus 12. And then 128 minus 80 would give us 48. So 48 plus 12 is going to be 60. So f of x is equal to 60 means f of 4, the function given to us, was equal to 60. Now we're gonna check that by doing synthetic division. We can just write the value again. Just make sure every time we do this, we write it in a descending order. So the function is 4, we already know that. I'm gonna divide it by 2, positive 2, negative 5, positive 6, negative 12. So I'm gonna bring down 2 here. 2 into 4 gives us 8. 8 minus 5. I'm gonna add all of these. 8 minus 5 plus, it's gonna give us plus 3, and then plus 3 into 4 gives us 12, and then we add these up, we get 6 plus 12 is 18, and then we multiply 18 into 4. 18 into 4, we would get 72, and then 72, we're gonna minus 12 out of these, we're gonna get 60 as our remainder. So as I mentioned earlier, we can do it by doing, if we have a function given, then we can put the function into the x value, and then we can find the remainder, and then we can check the remainder by doing synthetic division. But if it's not given, then we're gonna set x equal to 0, and then whatever we get, we're gonna do divide it, and then we're gonna check it by putting that value into x. So now we're done with that. We can continue and do our factor theorem. Factor theorem says if f of x is a polynomial, if a function of x is a polynomial, and then we can plug in the value of x as a, and then set it equal to 0, then x minus a is a factor of f of x. We can identify the 0 and factor by noting the value. And when the remainder is 0, we can do the synthetic division. We do the synthetic division. Finding one remainder of 0 can get us to the factor of the polynomial. Note that we have to completely factor the polynomials, as we're gonna find the simpler products. And then we are gonna find the value of x that makes x equal to 0. Now I'm gonna solve the first equation for the factor theorem. We have a problem which gives us the equation, and it's given that the minus 3 is a f of x. So we're gonna set x minus 3 equal to 0, which would give us x equal to 3. So we can take this 3 and then put it as in the value of x. So it's gonna be f of 3. It's gonna be, and then divided by x to the power 3 minus 4x plus x plus 6. So we'll take 3 and do the synthetic division first. We'll take 1 minus 4 minus 3 minus... Wait, it's gonna be 1 minus 4 minus 1. That's gonna be plus 1. Plus 1, and then minus plus 6. So when we do that, we're gonna drop the 1 down. We're gonna have 1 here, then we're gonna multiply it to 3. We will get positive 3, negative 4 would give us negative 1. And then we're gonna multiply negative 1 to 3, we would get negative 3 again. And plus 3, negative 3 would give us negative 2, and then negative 2 into 3 would give us negative 6, which would give us 0. So we got 1x, it was a cubic root, so we're gonna make it quadratic. 1x squared minus 1x minus 2. This is our equation that we get. This is our quotient. We can just write it without 1 as well, because that doesn't really matter. So once we do that, we would have to factor it. So we had x minus 3, which was given to us. So we're gonna take this, and then whatever we get as a quotient, we're gonna factor it. So we need something, this is a factor itself, we will need something that would add up to, that would multiply to minus 2 and add up to 1. So we can take as minus 2 and positive 1 would give us the answer. So we can write it as x minus 3. This is a factor by itself. And we can write x minus 2 and then x plus 1 equals to 0. We're gonna set each factor equal to 0 now. X minus 3 equal to 0 would give us x equal to 3, and x minus 2 equal to 0 give us x equal to 2, and then x plus 1 equal to 0 give us x equal to minus 1. So our answer is gonna be f of x, and the leading and f of x, which was equal to x minus 3 or x plus 3. it's gonna be x minus 3, x minus 3, x minus 2, x plus 1. There you go, there we have our answer. So now I'm gonna do one more factor problem. So in this we have our equation as 2 to the power 3, 11 to the power square, and then 11 by itself and minus 4. We are given that we have to divide it by x plus 4. So we will do the synthetic division first. So I'm gonna put x plus 4, set it equal to 0. I get x minus 4. So now I would do minus 4 divided by 2 plus 11 plus 11 minus 4. So I'm going to bring 2 down. It's going to give me 2 into 4 would give me negative 8 plus negative, it's going to give me 3. If I multiply 3 by negative 4 would give me negative 1. And no, if I do 3 into 4 it would give me negative 12. So if I add that up it would give me negative 1, and then negative 1 into negative 4 would give me positive 4. So they're gonna cancel out, is equal to 0. So now we got our quotient, which is x plus 4 was 2x. We had a cubic root here, now we're gonna put quadratic here, plus 3x minus 1. This is our equation now. Now we can factor it, or we can use the quadratic formula to simplify it and to get our answer. So I'm gonna use quadratic formula, which is gonna be x equal to minus b plus minus under root b square minus 4ac over 2a. It's gonna be minus 3, our b is minus 3, plus minus b square means 3 square, minus 4, our a is 2, and our c is minus 1. So minus minus is gonna plus, but it's 2 and into a is 2, we would get minus 3 plus minus 3 times 2 is 9, and then 4 times 2 is 8, 8 minus 8 is that's gonna be 17 over 4. We do 2 into 2. So we can write it into two terms. We can write it as x equal to minus 3 minus 17 over 4, or minus 3 plus 17 over 4. So we got two terms here. We can write these terms by making it look like a full function. So our a is a leading term, which was 2, and then we are gonna write what we divided it by. It was 4, and then we got our answer as x minus 3 plus 17 over 4. Right, it's gonna be minus plus 17 over 4, or x minus 3 minus 17 over 4. So a is our leading term, so it's gonna be f of x equal to 2 x plus 4, and then x minus 3 plus 17 over 4, and x minus 3 minus 17 over 4. Now we will learn about how to do rational theorem. Here are some few steps about the rational theorems, which will give some context about the rational theorem. When we see the word rational, that means ratio. When you think about ratio, we think about the comparing of two quantities in a fraction form. And what root means is that solution of the equation, it's what makes the equation equals to 0. So the way we find these rational roots is by taking all the factor constant. Sometimes we refer to that as P over Q, as we have here, P over Q of the leading coefficient. Leading coefficient, as we have our equation here, leading coefficient would be this one. And this number here in the front. So all the factor of the constant, meaning all the number, are divided evenly to 12. The integer divided by this are all 12. I meant this one and this one. So that divide evenly by 12. That divide evenly by 2 into 12, this leading coefficient. So if we were to do that, I will first explain some of these rules. We would have to check if the number of the polynomial, check if the number is 0 of the polynomial using synthetic division. Try a possible 0 by performing synthetic division. If a remainder is 0, the number is a root. If we get x equal to 0, or if we get a remainder equal to 0 by performing synthetic division, then we have a root. Then we can continue with the number that we chose to divide it by. If it's not 0, we can go to the first step, try another number. We can take another number that is a root for this. So once continue testing and possible rational roots until we find the one that works. If it is a 0, the quotient allow us to write the polynomial in factor form, just like we did that before. In the remainder, if the remainder is 0, then x minus c is a factor. Means x minus a is a factor that we learned. And the quotient is simplified polynomial. So start working with the smaller polynomials and repeat the process. Use the quotient step 3 as a new polynomial. Go back to step 1. Repeat until the polynomial is completely factored, and then this method only works if we know what numbers to try. We cannot just try any numbers. We need the rational zero theorem helps by giving us the list of possible rational roots. These are all the factors of the constant term divided by the factor of the leading coefficient. So if P over Q is a 0 of the polynomial, then f of x then P is a factor of a constant term and Q is a factor of the leading term. So if we were to do that, we can say this is our Q and this is our P. And what are the numbers that goes into 12 if we were to make 12? So it could be plus or minus 1 into 12, and then 2, and then 3, and then 4, and then 6, and then 12. And then for the 2, we can multiply by 1, and 2 into 1 is 1. So the way we write it is P over Q. So that's gonna be all the number that we can divide it to make 12, and then all the number we can multiply to take to make 2. So it's gonna be plus or minus 1, and then plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. And we can divide it by plus or minus 1, plus or minus 2. So we can take any of these term at the top and divide it by any of these number at the bottom. And come up with the possible rational root. We can check if we see a remainder as 0. It helps us to narrow down what we write when we write as a factor of the constant and the factor of the leading coefficient. We can write it as 1 into 1 would give us just 1 plus or minus, and 1 over 2 would give us plus or minus 2, and 1 over 1 would give us 3 plus or minus. It would also give us 1 over 1 would give us 4. It would also give us 6, and then give us 12. If we do it by 2, it can give us 1 over 2 plus or minus. It can give us 1 over 2 is equal to 2. I wrote it here. 1 over 3 equal to 3. I wrote it here. 1 over 4 equal to 4. These are all gonna be same. If we do it by 2, I just did it by 1. If we do it by 2, it's gonna be 1 over 2. And then if we do it by divided, 2 over 4 is gonna give us 2. And then if we divide 3 over 2, this we cannot get. This we did not write. We can write this, and then we can write everything else I've mentioned here. So we take 2 over 6, we get 3 over 2, we get 2 over 12, we get 6. So that is our possible roots that we can take and figure out for the polynomial factor. So this is a rational theorem. And then we follow those same steps. We take any of these numbers and we take it into synthetic division, and then we see if we get the remainder 0. And once we get the remainder equal to 0, we can factor the quotient, and we can see how many we can see. We can set x equal to 0. I'm sorry. So we have this term here. We're gonna use the same. Oops. Oh my god. what did I do? Anyways, we can use this term and this term. This is the same term. We have all figured the rationals of this equation. So first we can take any of these. We can take either positive sign or negative sign with it. We'll do the synthetic division. I would like to take 6 first. I would like to take positive 6 and see if it gives me the remainder equal to 0. So I have my terms here. It's 2. Wait, this is a 3 here. This is a 3. 2 minus 12 plus 22 minus 12. So I would bring 2 down. It would give me 6 into 2 is 12. So I get plus 12 here. It's going to give me 0. And then 0 into 6 is 0. It would give me 22 positive. 22 positive into 6 is 6. 22, 6, 12, and 13. It would give me 132. And then if I subtract that, it would give me 120. So this is not a root. We can see we did not get remainder as 0. We can try some other number. Maybe we can take positive 1 and see if we can get it. So 1 root 2, 12, 22, 12. So we're gonna bring 1 down. It's gonna be 2 into 2 give us negative 10. And then we would negative 10 into 1, we would get negative 10. And then if we subtract that, we will get 12. And then if we do multiply 1 into 12, we will get positive 12, and that would work. Wow. Our remainder equals to 0. And then we can write our quotient that we get by taking 1 degree down. So it's gonna be 2x squared minus 10x minus plus 12. So now it is in quadratic. We can use the quadratic formula to find the 0, or we can just factor it. But I'm just gonna do the quadratic formula. So we get the function f of x is x minus 1 is 2x squared minus 10x plus 12. So if we do quadratic, that's going to be x equal to plus or minus b. No, it's going to be minus b plus or minus b squared minus 4ac divided by 2a. So we will just put the value, plug in the values. It's gonna be, our b is 10. So it's gonna be negative 10 plus or minus 10 squared minus 4. Our a is 2 and our c is 12. Divided by 2 into 2, we would get plus or minus 10 plus or minus 100 squared. 100. 10 into 10 is 100. 4 into 2 is 8. 12 into 8 is 96. We get 100 minus 96, 2 into 2 is 4. So 10 plus or minus 100 minus 96 is 4 over 4. If we were to remove the square root, we would get 10 plus or minus 2 over 4. Our x is now equal to, so x is equal to 10 plus or minus 2 over 4. We can calculate the possible values for the x with this. So x1 would be 10 plus 2 over 4, which would give us 12 over 4, 3. So x1 could be 3, and then we can do x2 equal to 10 minus 2 over 4, which would give us 8 over 4, and then we would get 2 as our final answer. So I'm gonna do one more of the factoring of the polynomial by using everything we have learned so far with the rational theorem. So we have an equation here, x to the power 2 square, and then x power 3 plus 11 squared. So first we can see that it is not in a descending order. So I'm gonna put it in an order first. F of x equal to x cubed plus 8x squared plus 11x minus 20. So now our p is 20, q is 1. So we can do p over q, which we can get all the possibilities for 20 is plus or minus 1, plus or minus 2, plus or minus 3. Not 3, we can't do 3. Not 3. We can do plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. And we can divide it all by plus or minus 1. So we get our functions, and we can actually substitute any of this into our function f1, and then we can check if we get 0 by putting any of these values into our function, and we can check it with our synthetic division. So we get our function is f of x equal to x to the power 3 plus 8x squared plus 11 minus 20. So f of 1 is, we will take first f as positive 1, x as positive 1. We need to substitute this into all of these equations. So we'll take x to the 3 plus 8 into 1 power 2 plus 11 into 1 minus 20. So we'll get 1 into 1 is 1 plus 8 into 1 is 8, and then plus this does not look like a bracket, but it's 11 into 1 is 11, and then minus 20. So if we add this, it's gonna be 8 plus 1, 9, 9 plus 11 is 20. If we minus 20, we get 0. We can check if it's correct by putting this and doing it as synthetic division. So we know x is equal to 1 now. Our function is 1. So 1 into 8 in 11 minus 20. This is our equation. We're gonna bring 1 down, and then we're gonna multiply it by 1. We would get 1, 8 plus 1 is 9. 9 into 1 is 9. 11 plus 9 is 20. And 20 into 1 is 20 positive. We get 0. So our last question that we get, this is a remainder, and the question that we get is x. We had this, the first leading coefficient with a cubic root. We're gonna do this quadratic here. Plus 9x plus 20 equals to 0. Since this equation is quadratic, we can factor this, or we can do it with the quadratic formula, but I would just factor it. So we need something that would multiply to 20 and add up to 9. So we can take 4 and 5. Positive 4 and positive 5 would add up to positive 9 and positive 20 if we multiply them together. So x plus 4 and x plus 5, we're gonna set them equal to 0. Therefore, this is our factoring for this equation that we did have here. We have two factors now. We can set them equal to 0. X plus 4 equal to 0 would give me x equal to minus 4, and then x plus 5 equal to 0 give me x equal to minus 5. Since our leading coefficient use a degree of 3, we can, so we get 3 factors, as we can say. X plus 1 was our function that we used, and then we got x minus 4, and then x minus 5. So the multiples of 1 is, multiple of this factor is 1, multiple of this factor is 1, multiple of this factor is 1. So this is our final answer. F of x equals to x plus 1, x minus 4, x minus 5. So this is all about the chapter. I hope you understand it. Thank you.